Hi, this is Bob Fossil. In this video I'll be showing some new features of my fossimon monitor program for div MMC and Exydos. This sort of whole branch of new features started from a post on the SpectrumComputing forum. It was about Pac-Man clones on the Spectrum. One of the Pac-Man clones that was mentioned was a modern version of Pac-Man called Spekku-man, and one of the follow-up comments on that forum thread was somebody said, yeah, it's a good version, but there's too many lives. It's too easy. So they were asking, you know, would possible be nice if there was a poke that reduced the number of lives in the game. So I was away from home, so I got my laptop with me, so I'd had a look at it with Fuse emulator. Managed to find a poke to get the 5 lives, I think, down to 3, but then that got me into sort of another problem, which we'll come across in the video, which managed to solve with the emulator and the debugger in Fuse, but then that sort of got me down the rabbit hole of, well, could I solve the problem if I didn't have an emulator, and how would I do that, and could I use fossimon to do that? So let's load in the game and start with that first. So if I go to the browser here and then attach that, because we're going to load this in through fossimon, so we can see what's going on with the loader. Break it there and go into fossimon. Then use the user command load, which will load in a basic block but disable the basic auto run. So we can have a look and see what the loader's doing. So we've returned to basic. That's not making a lot of sense, but I suspect it's the rem statement is holding the machine code, and then you've got a clear 0 and a randomized USR 0. Those numbers aren't right, because randomized USR 0 would reset the computer. So let's have a back into fossimon, and then we'll use the list user command. And yeah, those numbers, those zeros, were tricks, because you can obfuscate the numbers in basic if you know what you're doing, but the list command in fossimon can strip away those. So we're doing clear 24576, then randomize USR 23791. So if we disassemble 23791, so yeah, XOR out, that will black the border. Then we load the attributes with 0, that will black the screen out. Immediately I'm suspecting that IX and DE and the call to 23901 is a loader call, because the ROM loader uses parameters like that, so bear that in mind. We'll carry on disassembling. Again, we've got more IX and DE and another call to that 23901. And if we see 23901, that's actually got load A, 255, set carry flag, and then jump to 1366, which is the ROM load address. So that 23901 is going to be loading files from the tape image. And just before that, there's a jump to 24576. So what I'm going to do, break there. I've got a breakpoint on that 23898. We can't put a breakpoint on the 24576 because the way that the break works in fossimon is it puts a opcode in to jump back into the monitor, but if the tape loads over that memory address 24576, then we're going to lose our breakpoint. But we should be safe if we put the breakpoint on the actual bit in the loader, because hopefully the loader won't overload itself. But it's not beyond the realms of possibility. If you've seen some loaders on the Spectrum can load over themselves. It's just keep you on your toes, but we'll put that breakpoint there, exit back to basic, and then start the game, or start the loader. So we trace that, so now we're at spoiler alert, I'm going to save a snapshot here because we'll be coming back to this code quite a few times, and it will just mean that we don't have to mess about with the tab file. So that will take a while to save, but it should be faster when we load it back in. Nearly done, are we? Can never remember how many dots it takes to for the full save to complete. So as you can see, we've got 5 Pac-Man graphics there, so that gives us, we've got 5 lives. So I won't spend too much time on this because this is not really what the bulk of the video is about. But if we remember, that address was 24576. So if we do the lazy person's way of doing this assembly would be just to have a load accumulator with 5. So if we do a search for 3E05, I say lazy, I've done this for my games, so I'm you know, it's the obvious, I say not lazy, it's the obvious way of doing it. If you don't want to spend time obfuscating your code. 24576. So that's quite close to where we started off. 24576. So we've got load A, comma. So just 24588. Put that 24576. That. And for viewers at home, this video does contain scenes of me trying to play Pac-Man, or Spekku-man, so I do apologise. Come on, So something to flip because it's took out the middle Pac-Man. So this was the problem. It's quite easy to find the lives counter, but then this was the other problem. You've got five graphics printed, but we've only got 3 lives. So if I go back in here, so this was the issue. This is like, would it be possible to somehow track down? And it was possible because I managed to do it with the emulator, but that was, you've got like a full monitor and debugger, and you could just put breakpoints on various things, and it became very easy to find out what was going on. How are we going to do this with fossimon then? First plan of attack, which is similar to how I did on using the emulator was to actually find out where that Pac-Man graphic was on the screen. I've extended the screen command, so normally, as I did in the previous version, screen command shows a screen, but if you press C now, we've got this little cursor we can sort of nip about with. I wondered if I could actually find the address of the Pac-Man on the screen. Maybe I could use that to find out where the code was that was writing that to screen. So if you press, let's see, press enter, that gives you a sort of little stats. So if you move around, it will also give you the XY, the screen address of that character cell, the top left, and then the attribute address. So we're looking for something that sort of modifies 20664. Let's go back, let's exit that, and then, as I said, go back here. From what we know, that load A, 5 happens after that call 49152 and the call 60599. It's one of those calls, because we know that load A happens after the screen's been printed. Let's put a breakpoint. Oh, let's break out. Let's put a breakpoint on 24584. So let's see whether that 49. There's nothing been printed to the screen so far at that point. It's looking that whatever is drawing to the screen, it's happening in this call 260599. So if we trace that and just have a little bit of a disassemble, again we're seeing some familiar code now that looks like it's clearing the screen to black and then setting the attributes. This is the point now where, if we're using an emulator, we could just put a breakpoint on the address that we found out earlier, the 20664, and then just let the emulator do the work for us. But with fossimon we can't do that, so I had an idea that if we could somehow watch an address for a change, and we could do that with the trace option. So I've added the ability now in the trace code. You can actually set, there's an instruction, well there's a thing added now called TW, which is a trace watch. So if I break out of that, well, first thing I think it's going to trip up on that bit of code that's clearing the screen. So what I'm going to do is I'm going to breakpoint 60621, which is the code after that second LDIR, which is the one that will do the attributes. So if I put TW trace watch 20664, which is our address in screen memory that we're looking for the part of the Pac-Man graphic to be drawn to. So that's come back okay. And then if we disassemble 24576, which is the initialization routine that we've been coming back to, so we want to run the trace until we get to 24587. And remember from the previous video, if we do a trace with a minus instruction, it will just let the trace run, because normally when you run the trace you get the register output so you can see what's going on, but we just want to sort of run the code, trace up until that point at address 24587, and now every time the trace executes, because we've done that trace, that TW command, every time it executes an instruction during the trace, it will then check that address for a change. So at the moment that's been set to 0 by that LDIR at the top of that call that we were just traced into, that top of that call, that's 60599. So fingers crossed, if we, so this is going to take a while because it obviously it's sort of tracing through and then it's checking the memory and every opcode it traces through, but it'll get there in the end. So famous last words. The other thing you'll notice with the trace now is that it will automatically sort of, if you set it to trace to a particular address, it will now carry on until it sort of gets there. So whereas before you'd be constantly swapping in and out and you'd have to press trace, but now it'll just sort of fire off. But good news, we've got the message back from fossimon that it thinks that the address 20664 has been modified and it's broken in. This should be at the point where something has modified that part of the screen. So if I disassemble, so looks like we've jumped in, we're in the middle of something. We've got popping, returning the stack. So I'm going to put a break out of that, break point on that ret 29737. If you just saw that there, we'll just confirm with the screen command. We've just drawn the graphics, the Pac-Man graphics to screen, so we know we're in the right spot. So if we break out of that, trace, because we're currently on that ret, so we're at 60687. So what we normally will just back up the disassembly a bit so we can actually get a bit of context. So it looks like it's the call to that function at 29690 is doing the printing of the graphics to the screen. DE, I would suspect, is the screen address. HL is I think might be the data to be printed to the screen, but we can check that in a minute. BC, don't know. A70 maybe an attribute because that would be the yellow colour, maybe. 64 would be bright and plus 6 would be 70, so that would, and 6 would be yellow, so that'd be bright yellow, so maybe that. But I've added in another new command. We can actually look at the graphical representation of the memory. So if we do 57873 and then we can then crunch this down. So yeah, those look like the Pac-Man graphic tiles. So yeah, it just shows the memory as graphics in a linear format. So looks like we've hit the font data there. So you see a nice way to sort of if you wanted to sort of rip fonts out of memory or see what data is what. So if we go out of that, so where were we? We were There we are, 6, there we go. So one of those, if we're lucky, one of those parameters will control what's being printed. So I'm going to switch to hex because that might make some of the parameters a bit clearer. So I've added in another user command which does a fast switch to, and it's a temporary switch. So if I disassemble 60670, so we've got BC, that could be coordinates or width and height or some such. That's 0B 08. So if we do load our snapshot again, just so we go back. This is where we bit of trial and error now. So if we say poke EDO, let's have a ED07. So if we do ED08, poke ED08, and as we see that 08, that will, if we try and maybe change that to 4 and disassemble ED07. So we're going to do B4 to break out that. So if I we look at the screen we've got now, we've managed to change the code. If I so we change that to 4, 2, 3, 1, 2, 3, 4. So maybe if we break out of there, I'll leave curse mode, break out of there, do that. As you see, we've switched back. We do poke $ED08, put 5, do that, and the other thing we need to do would be to poke 600. 600C with 3. So I disassemble ED07. So we've changed that to try and hopefully print the 5 characters, and then we've changed 600B to give 3 lives. So if I break out of that, so we've got our 3 Pac-Man graphics. So if I press So there we go, we've managed to track down a bit of code which we didn't really know where it was, but we used the screen command to sort of give us a screen address. We then used that to put a trace watch on, and then we used the trace command to sort of slowly go through, and that told us when that address had been modified. So there's the new graphics command as well, so that can let you search through memory for graphical data, for fonts and sprites. The trace itself, now that if you use the trace up to an address and use the minus command, that will automatically continue the trace when it switches out of the monitor to do an instruction it can't handle, and then switch back. The trace code itself, I've spent quite a bit of time on that, so now that supports a lot more instructions. So if you are just using the trace normally just to trace through stuff, you're switching out of the back and out of the monitor a lot less. It can handle call instructions, it can handle returns, it can handle loads from memory, loads from registers. So I think it's just like the LDI, LDIR, CP, CPIR, LDDR, LDD. So it's like the block transfer commands. I've not supported those yet. So, but most of the other instructions now will just trace directly. So it just makes tracing a lot easier. You're not continually sort of flicking in and out of the monitor, then back in and back out. So it's just a bit more fluid experience. I'd say the other thing as well, there's also an improved directory command now, so that will show file size is greater than 64K, and it will also show the date of the file. So yeah, just little things, but yeah. Version 5 of this is still in beta, so I haven't released any of this yet, so so that might be the next week or so I'll make this version available. So yeah, that was just a slightly roundabout way of doing something that you could have done in an emulator in about half the time, but you know, keeps me off the streets, doesn't it? So thanks for watching this video, and I shall hopefully see you in the next video. Bye for now.